let's now see the concepts of mean, median, and mode, Sashi, with Python.
Yes, sir.
Inside Python, how are we going to compute it? So for which first,
Okay.
what we'll do is we'll create a data set of like few records. We'll not get into file for now because first let's work with smaller records. Once you guys are comfortable with the smaller records, then let's get into bigger files and this. So what is the package that I need to import? I'll be importing NumPy
NumPy.
as NP, right? And next, I'm going to declare a data. So for the data, basically, I'll create a list, right? Like 160, 167, 165, 170, 175, 180.
Okay.
Okay. So these many data points currently we are having.
Okay.
Okay, and first let's execute this and make the cells ready for us to look into. In this also later on also we'll spend some time looking into Power BI as also, Sashi, because visualization is also required. So what we'll do is we'll just take some simple exercise in Power BI and try to just do very few exercises. We'll not spend more time on that, but maybe that is also required in the current industry. Whatever we are seeing, right, from the interview perspective, they are asking for everything. So it is
Yeah.
better to have that understanding as
In
well.
your organization, which one you are using, sir?
We are using Power BI, Sashi.
Power BI.
We
Yeah.
are using Power BI. Mostly, I use Python only for visualizations. But what I'll do is I'll use like in parallel Power BI also. So once I'm creating the model and deploying it, and the model is getting executed, right? So to show the performance of the model or how it has been performing over a period of time, what has been the results, and these things and all, like.
Where you will deploy this one, sir?
So, two things what we do is generally, Sashi, we'll create first a model. So after
Okay.
you create a model, not only one model will directly fit in. So you have to iterate with multiple models, right? So one will
Okay.
be a normal linear regression, logistic regression. Then maybe you will go ahead with supervised techniques, unsupervised techniques. You will use random forest, gradient boosting, or and maybe you will, if you are not satisfied with the results, you also go with the neural networks. So in neural network also there are high performance neural networks are there with hidden layers and this. We try with various combinations. Okay, so
Okay.
after trying out all these models, then we'll do a model comparison. So which model has produced less misclassification, less error, which model has given. So depending on our problem, we'll need to
Okay.
pick and choose various, either error rate will be in some cases, misclassification will be in some cases,
Yes.
in other cases it will be false positives, true positives. So mostly we'll be considering everything put together and we'll try to do a comparison between the models. So
Okay.
once we take everything and we have compared the data, then we get a then what we do train and test split. So training data, what we'll do is out of 10,000 records are there. I'll not take
Okay.
all 10,000 and train the model. In that, I'll
Yeah.
take only 8,000 and I'll
Hmm.
keep remaining 2,000 as a validation set for me. Right. So what
Okay.
I'll do is I'll train the model with this 8,000 records and then I will try to validate this with the remaining 2,000. And I'll see like how the model is able to perform for unseen data. The records what the model has not got trained into, how it is performing there.
Okay.
So then I'll measure the training accuracy, validation accuracy, and after everything is convinced and after all these models are okay, and one best model will be chosen, and that model will be taken, and I'll be deploying that particular model into production system. So
Okay.
so once I create the model, right, what happens is basically we will generate a model's equation will be generated. If it is a logistic regression, there will be a final equation that will come out. So that equation is the one which will be used for new data. So I would have trained the model until June 2025, you assume.
Okay.
So then what I do is I validate it from August, September, October onwards with new data.
Okay.
Right. So then I try to see like, okay, how many conversions are happening if it is going to be a marketing model. If it is
Okay.
going to be other kinds of models where you will be like trying to see like what is the revenue that is coming out of this,
Okay.
has the model been really working out or not. So we'll evaluate it. We'll run a live testing for next 2 3 months and try to see
Okay.
like how better the model is performed. Okay.
Okay.
Now what happens after like 6 months, 7 months, the model is stable. See, the model also follows this normal curve,
Means,
what we
yeah,
discussed
if there
yesterday.
any data changes between,
Yes, exactly,
uh,
exactly.
then the model will be need to update it, and or it
Yes.
will
So
be
what happens is, yes, very good question. See, what happens is once the model is deployed and it will run. So first few months, the result will be really high. Very nice it would be. And like for first 6 months onwards, the result will be very good.
okay
Right. And
until first
after
six
six
months.
months, yeah, after next 6 months, slowly the model starts to underperform. Okay. Because what
Why,
would have
sir?
happened? Because no, I'm saying in not in every case, right? So because you see, you have given model certain data only, so it got trained based on certain records only. Now the customer pattern would have changed. There would be new seasonality would have come. So
Hmm.
and the buying patterns would have changed. See, earlier we used to market only through TVs, radio, newspaper, and that. Then after that, the marketing channel changed, right? Now it came to ads, YouTube, and this. So due to technological innovations and change of customers' behavior pattern also, certain thing changes, right?
Okay.
Earlier we were reluctant to do any online order. Now we are only doing online order. We are reluctant to go to shop and do the shopping because we feel it is a waste of time,
Yeah.
right? And we are doing everything as online, no? So the pattern has changed, right? So in order to capture the recent patterns of the day from the data, what we do is then we try to re-estimate. So for example, earlier I would have found like 10 key variables which were contributing for my model.
Okay.
Now, after new data has come, now there is 12 variables which are now there. So that I am finding two more variables which are more correlated with one another.
Okay.
Okay, so in that scenario, what you have to do, you have to basically reconsider the new variables and try to retrain the model with the new data.
Retrain it. We need to modify the existing model.
Exactly. Existing model itself you will be modifying. You will be creating a new model by itself.
Okay.
But existing variables will be there, but you might be adding more variables.
Adding.
Yes.
Okay.
And in
Okay.
some cases also some variable might have become redundant. Okay, I'll tell you. For example, earlier we were in banks and all, we were using something called e-wallet. Okay.
E-wallet.
Now
Yes.
this e-wallet concept is no more there. Now mobile banking has come. So whatever
Uh,
transfer and this, what we used to do is we just used to transfer it to their direct mobile number itself. So after now, this the e-wallet concept got redundant and it was no more very much useful, right? So now in case my previous model, I would have considered e-wallet as one of the key variable there. But now I know from after discussing with the business, okay, this is no more required kind of. So I stop using it, right? And
okay.
I try to find out new variables which are contributing for this model, right? And then I do a retraining of the model. And also now what happens is, see, as of now, we might have done with a basic model there. And after like 6 months or so, they would have created a new algorithm would have come. So,
Hmm.
and that would have the drawbacks of previous algorithm what you are using. that would have been fixed in the new model, kind of, right?
Okay.
Then what you do is you update the algorithm itself and then try to reuse something really new,
Okay.
right? So that is how, that's why this field is a
When it
constant
is
evolution.
it will be continuous running, sir, where the jobs are running. It is deploy into GitHub,
It
right?
it cannot be like that. Maximum a model can be reused for a year's time, Sash. And after that 1 year or so, if you're going to use, what happened in my real-time scenario, I'll tell you.
Yeah.
So before I joined the bank, I was in India. So they had called a few consultants. So we were basically working on a insurance project. So
Okay.
insurances, who are the people who will be buying insurance, not buying, kind of. So there were people who were coming from, they hired few data scientists and few project teams. They spent in like $100,000 something just for
Okay.
building one model. Okay.
Oh my.
And
Okay.
yeah, just for building one model. So the
Okay.
guys came and they came to our premises and taking the bank data. They were trying to create and they created a model.
Okay.
Okay. And the model was then after that they said like the model is working good, and they tested, they did training, validation, and everything they did, and they concluded, okay, the model is performing really well. Okay.
Okay.
Then they deployed this model.
Okay.
So like the model ran fine for 3 months. From fourth month onwards, there was no retraining done. Okay, the same model was used. Slowly, what has happened, as you see in this bell curve, Sashi, the model was at peak in 3 months only. And after that, slowly it started coming down. So when the model was now used, more complaints are coming. No more conversions are happening. And it became a very big problem for our
Okay.
business. Then what the business head did is he told like, okay, I think this model is not working anymore. Let's stop the model. And they were
Uh,
running it manually, kind of like trying to pick and choose the filters, and they were doing something.
uh,
And because of this, what has happened is the number of complaints started piling up. Why are you guys calling so many customers without, and they are not interested? The same customer is getting called six,
uh,
7 times.
okay.
So
Means
they
it,
got
it is the
total,
target. The model is targeting to new customers who have the interest.
who have interest or who has the capacity to buy insurance.
Buy it. Okay. Now the model means the how the model when where it is running means it is connected to database model. Okay.
Yeah, no, the model where
How
it
it
will
will
run.
workflow how it will be.
Okay.
For
See,
example, in BI, our example, we take it from multiple sources. We make
yeah,
a data transformations, data warehouse, something. It will run in the SQL Server jobs.
yeah,
Okay.
yeah. So here
Uh,
everything will run in
how it
the
will?
Python only, Sashi. What will happen is there will be various environments that would be created. So
Okay.
first will be a test environment, development environment where you will be building the model. Once
Yeah.
you are creating the model and it is going to be deployed, then they put it in UAT, and the
Yes.
testing will happen in UAT. And
Okay.
after UAT testing is done and it is approved and it is running fine, it is not causing any other challenges to the other models or programs that are scheduled, then it
Okay.
goes to production. So once it is going to production, the model, what will happen is it will not run by itself, right? You have to prepare the data because I will be needing 10 key variables, and the variables have to be in this format and it needs to be transformed in this level. So for example, I'll tell you, I take in my model, for example, I'm taking seniority calculation if it is there. So I wanted to know
Okay.
who are my customers within 1 to 2 years, 2 to 3 years, 3 to 4 years. So my model would have assigned different scores for each and every parameter here. So if it is 1 to 2 years, then my overall score would have been like somewhat less. So 2 to 3 years, as the tenure of the person increases, the weightage also increases more, right? The parameters weightage also will increase more. So
Yes.
in those scenarios, what happens is I need to supply to the model in that format only. So I cannot just like that supply, okay, 10 overall 10 years. That means the model will not run only, right? So I need to prepare the data in such a way and then supply that amount of data only to the model, right?
Okay.
You
Yeah.
cannot just like that give any data as it is. So you have to prepare the data and then that data has to be consistently supplied in the same format only. Then only the model will execute it. So then we take it to the production, and then in production is what we will be testing this model out and trying to see like how it is running, how many iterations we were able to run, and what was the result, and we'll try to evaluate it every now and then.
Yeah. And when the run make it model, it is
Hello, sir.
normal distribution.
Yeah. Hey, hello, Raghav. Hey.
Sorry for delay, sir. Here some
No,
issues.
no problem. No problem. No problem, Raghav. We were just discussing about modeling and that aspects only. We have not started the class yet. That's okay. Yeah. Yes, Sashi.
For example, we have a model, we make it a normal distribution.
Hmm.
Okay. When the
Hmm.
records which is perfectly match the normal distribution, how you will get the output for the targeted customers?
Okay. See, it depends on your problem also, Sashi. So if your model is going to be a binary classification model, either it is going to predict 0 or 1. Okay.
Yes.
So what it does, it is assume it is going to be a propensity model. Okay. So what it does, it basically assigns a value scores from 0 to 1. So 1 being the highest and then 0 being the lowest. So it
Yes.
basically assigns values for me. So what I do is based on what my model has predicted, I'll be putting a rank on all my customers. And I'll say these are the customers who are having more than 60% probability that they are likely to buy because of these factors: higher salary, their age band is this, the number of dependents are this much, their organization, they are working in tier one organization, and the home, they have been in the bank for last 5 to 6 years. So these guys are having higher probability to buy this particular product. So in
Yes.
that case, a probability score is assigned, and then I target only those customers. Okay, so this is for a binary classification model. So in case there are other models also, for example, you are going to do a sentiment analysis. So in a sentiment analysis, what you will be doing, you will be taking a data of chat data. Basically, you will be taking Facebook data or something like that. And then from that, what you do is you try to classify the sentiment of that particular conversation. You'll be saying whether this is a positive sentiment, this is a negative sentiment, this is a neutral sentiment, or are the customers really happy with the service or they are unhappy. So in this scenario, the problem itself is very different, right? So here we will be trying to predict the sentiment of the customers based on the words and things that they are using for chatting or using the call center data, something like that. So similarly, for a credit score model, that will be very different. So in a credit score model, what you will do, you will basically say like, who is the customer who is likely to default, right? So you will
Yes.
try to predict the customer who is likely to default on the loan. So
Yes.
why, how will you predict that? You will basically predict the default rate of the customers based on their historical spending pattern. He is
Yeah.
a high spending customer who he always exhausts his credit card limits. So he is surviving with his next month's salary only for this month credit. So basically, he uses his credit card and he swipes everything in the credit card. And next month, once the salary comes, he pays everything in credit card bills, right?
Yes.
So
Yes.
this is a high risk customer because there is a possibility that if his
Yeah.
job
There
is
is a
not there,
score.
Yeah.
when you use more utilization of credit card and
Yeah.
not paying due basis within
Yes.
the
Yes.
due. It
Yeah.
is there are some parameters. This is fixed, which
Correct.
we know.
Correct. So how many
Yeah.
bill payments this particular person has made correctly? How many utility bills is he paying on time? How
Yeah.
many telephone bills has he paid in the past? And how frequently he does a transaction? So if a customer is withdrawing too much of cash, also that customer is considered as high spenders, right?
Yes. Yes.
So too much of cash withdrawal is also danger, or he is trying to transfer money always, or trying to do something or the other. So in that case, he doesn't have a lot of money left with him, right? So these are
Yes.
like high spenders and risky customers. So we'll come with the risk scores for each of them and we will try to predict. So this is a risk-based model, Sashi. So
Okay.
depending on your problem statement, what kind of model you are supposed to use, how you are going to use, everything will change and differ across.
What tools you use, sir, in
Okay, so here we are using multiple tools, right? So in my organization currently, we use SAS E-miner,
SAS
Python,
email?
SAS,
Okay.
SAS E-miner, Python,
Uh,
and I generally use Jupyter notebooks plus Python there, or mostly I use Spider also at times. But mostly in for data science applications, I use SAS E-miner and Python, because SAS E-miner gives me a server there, so I can consume the server's memory for running high complex models and all. I can use that. And Python I generally use for rest of the other tasks. Data
okay.
pre-processing, finding the descriptive statistics, putting it across, building the model and deploying and all
SAS
these. Yeah.
is SAS is a server?
SAS is a statistical analysis software, basically.
Yes. Yes.
This is these guys are pioneers in data, Sashi. These guys have been there in the industry since 1960s, 50s and all. Okay. So
Okay.
they are very old in terms of this. So these guys, in fact, have created all these concepts in the year 1990s itself. Whatever we are going to study now, it is a statistical analysis software. So basically, they have everything pre-built inside. So seeing them, only many of them evolved actually. Python and all came later, but even before that, SAS was there. But only problem with these guys in SAS is the licensing cost was very high. So that
Okay.
being the reason why not every organization could use that, because of the very high licensing cost.
Okay. We will you teach something about this one also, sir?
Yeah, yeah, I can teach you on SAS also. See, it is just like an introduction kind of. I can tell you how to work on and do things. But for you, what I'll be suggesting is you and Raghav try to understand the concepts more. See, the
Yeah.
concept, if it is going to be the same, either the implementation way will be changing in Python and it will be changing in SAS, or in
Okay.
R, it is going to be slightly different. But only
Okay.
thing is the concept remains the same. So
Yeah.
try to
Got it.
understand from the conceptual perspective.
Yes. Yes.
So
Yes, sir.
that will
Little
give
we
you
need
a,
some knowledge on tools also, right?
yeah, yeah, very much, very much. Yes, we will be
Yeah.
discussing.
Okay. Okay. Let's start today class.
Okay,
Okay.
Raghav. So we were just discussing, Raghav, about what the data science, how real-time project works, those things and all. Okay.
Okay, sir.
Yeah. In today's session, we'll be seeing about, because yesterday when we started seeing about normal distribution, suddenly I felt like, okay, maybe you guys are not confident enough to look into. So let me come to some basics and then we'll go on with, right? So what I'm going to do here is I have created a NumPy data set. This is a list of all items I am just creating. So in this list, basically what I wanted to do is I wanted to compute the mean of this data. Okay. So how I can compute the mean of this data? Basically, I'll be creating a variable called mean. So for this mean data, there is an inbuilt module in NumPy called mean. So I'm just going to make use of that module. So that function, so basically np.mean of, I'm just going to supply this data across. So how is a mean computed, Raghav? How are we going to calculate a mean?
Mean for the
Uh, Sashi, were you able to hear anything? Maybe it's just my side or
No, sir.
okay. Raghav looks like there is some network issue. Okay.
No, sir.
Sashi,
No,
you
sir.
can
It's talking. It's talking.
okay. So how do you compute the
Yes.
mean?
The sum of the 160, these are values by total average, right, sir?
Yeah.
Yeah.
Yes. Basically, it is just going to compute, take all the values and then try
Divided by
to do. Yeah, exactly.
divided by 6, sir. Yeah.
Yes, divide by the
Divided by
total number
6.
of values.
Yeah. Average is mean is average.
yeah, calculating add total number divided by the n number. It's
Okay, so basically what I'm going to do is I'll just going to compute the mean. So what does this mean? It is 169.5. Okay, just keep this data in mind. Okay, the mean is how
Okay.
much? 169
160.
point. Okay, so what happens is yesterday I was telling you mean is the value which is very much disturbed by the outliers. Okay, now I'm just adding one value 0 to this. Did you see what has happened?
Mean it will be change.
Mean has drastically come down, right?
Yes.
So assume like I'm having more zeros added.
Yeah. When we have high values, if you add the low values, the mean value will be
You see,
decreased.
it is further coming down. So
Yes.
mean is always affected by outliers. So what is outlier? This is outliers. So for example, instead of this, I'm going to give
Ah.
1000,
Okay.
right? 1000 I'm going to give. Now you see what is going to happen to the mean. Did you see? Is the mean somewhat closer to any of the value? It is too high, right?
Yes, sir.
So mean is always affected by outliers, right?
Yes.
So what do we do in case if it is getting affected by outliers? What are we supposed to do? Sashi, Raghav.
I think I did somewhere. We bring this value to mean, mean, sir.
No.
How I don't.
Okay. So Raghav, yeah, what do we do in case there are outliers now? So what do you do now? I'm not sure if your network is going to allow you to tell this answer, but in case not, it's okay. Raghav, fix your network, Raghav. There's been like your voice is totally no, we are not able to hear you anything. Are you connected from your mobile network or something?
Raga?
yeah, yes, sir.
Oh, maybe that's why it is okay. Fine. Okay, fine. So what we generally do is whenever this mean is getting affected by the outliers here, right? So in order to, when there are more outliers and the mean value is too much skewed, right? So now the mean has gone somewhere else and the data points are somewhere else. So no, because this we can call it as skewed data because it is very much getting affected by outliers. So for this scenario, what we do, right? So we use something called median. Okay. Now let's see what this median does basically. This median is the one which is just going to say, um, it is going to take the middle value of all this. So for example, 1, 2, 3,
Yes,
4,
yes,
5,
yes,
6.
yes.
We have, right? So what it does, it takes 1, 2, third and fourth value,
Median
right? Third
values.
and fourth value it takes and it divides by 2, and then it computes a middle range value, or it basically takes this and this value. So whatever is the middle value for this particular numbers, it computes a median for that based on that. Okay. So now I'll show you when outliers are there. Let's
It is.
add some.
It will be replaced by the median values.
Yes, you see now. Now I'm adding some outliers. Let's see the mean value. You see the median value. You see? The
Yes.
median value is not affected much by the outliers, right? Because what it does, it doesn't. So assume like I'm adding 1000. Okay. Okay. Now you see my mean value shot up to 288, but my median remains the same. You
How it
see?
will calculate, sir? How it will replace the value with 1000? Means it will take
Uh,
the.
no, what it does is basically it doesn't considers the last value, first value and all. It just takes the middle value alone. So if there are 7 numbers, right, which is the middle value? 1, 2, 3,
Okay,
4.
170.
170 is the middle value, right?
Oh,
So
yeah.
it takes 170, right?
If you
So
add
it
one more,
doesn't,
then it
yeah,
will be.
yes. So another 2000 also I'm adding.
Then
No,
175.
yes. Now you see the mean has shot up to this. Now it has
172.
just gone to 172, kind of,
Okay,
right?
yeah, say 170. Okay.
175 plus 170 by 2. So it goes to 172. So you see, this is not affected much by outliers at all, right?
Yes.
Just note down this concept very keenly, because this is something we'll be using in our day-to-day problems also. When we are going to solve a real-time modeling problem, we'll be making use of these concepts there.
Yes.
Okay. And there is another concept. So median is also useful in certain cases, but the problem with the median is you need the data to be sorted in a particular order and kept in a certain order. So assume like here I'm going to have some values like 170 again, 190, 180, 170 again, and 160. Okay, assume I'm having these values. Okay, so whenever there are no outliers, mean is okay. So it will be, we can rely on mean. Okay, but what happens is, in some cases, what we also do is we run a concept called mode. So have you heard about a concept called mode?
No, sir. I didn't.
Okay. So mode is nothing but it is something like what value occurs mostly in your data set, that value will be considered. See, in some scenario, we'll be considering mean. In some scenarios, we'll be considering mode, or in some scenario, we'll be considering median also. Okay. So when are we going to use what is something that we'll be seeing now. So when in a data science perspective, um, when to use these is really very, very important. So just keep this in mind. When where you use a mean for symmetrical data, whenever there are no outliers, symmetrical in the sense, when there are not much of outliers, I can, for this particular problem, I can use mean also and mode also. So it will not make much difference for me. I'll show you that as I explain it to you for me. But if the data is skewed in the sense there are more outliers, right? In that case, median will be a better choice, right? And the mode is something when we will be using it is mode is something which is the most occurring value. We will be using mode for non-numerical data, non-numerical or categorical data. For example, I can say male and female, gender is there, right? So one particular value is having a lot of missing values. So what do you do? Can you take a mean of gender or median of a gender? Right? It will not make much sense, right?
Yes.
So in those scenarios, what you do is you take a mode of the data. Mode
Which
means,
age is more?
yeah, whichever, which gender is more. For example, if female are more, we'll consider the missing values as female. If
Yeah.
male records are more, we'll consider the missing values are as males.
Yes.
Right?
Which
So in
is
that
category.
scenarios, yes, exactly. Categorical columns. Yes.
Okay.
Okay. Just keep this in mind because this is a very, very important concept. And in interviews, most of the interviews also they ask this. When do you use mean, mode, and median? Whenever you are going to replace your data, what do you use and why do you use? Right? So that is a very key important question there. See, mode is not directly available in NumPy. So we are going to import a new library called SciPy. Import SciPy is nothing but scientific Python. Okay. So we say that as scientific Python as SciPy or SP SciPy, scientific Python. Okay. So what this does is scientific Python is also very similar, but here in the scientific Python only, we have a method called mode. So in order to use mode, I'm making use of this SciPy, scientific Python, which we'll be using for hypothesis testing also, this particular library. Okay. So now what happens is I'm saying mode of this data and print the mode. So first compute the mode and then print the mode from this data. So what do you think will be the mode of this data, Raghav, Sashi?
Which date this data 160?
What will be the mode of this data?
Checking, sir. 170, sir.
Okay. Raghav, I hope you also agree with Sashi. Let's see what is this telling. Yeah, int of 164, mode result, which is 170. So it is also giving us a count, which is 3 times this particular value has occurred. And the value what has occurred is 170. Right? So this is how you compute the mode of this particular data sets. Is this clear, Raghav, Sashi?
Yes, sir.
Okay. Let's move on to our next concept. So now the 3 things, the mean, median, and mode, what we saw, if the mean equal to median equal to mode equal to 1, okay. So if everything is 1, then this is a perfect normal distribution. Okay. So you asked me a question yesterday, Sashi, sir, how to know whether it is a normal distribution or not? So I told
Yeah.
you we generally put a bar graph and we'll try to represent it in form of lines or
Uh,
curved lines, and then we'll
yes.
try to see. So that is one way of seeing. But if from the data itself, if at all you wanted to see whether it is normally distributed or not, you first compute a mean, then you compute mode, and you compute median. If
If all
mean,
in
median,
near,
yeah, sorry.
if it all result near, it will be normal distribution.
Yeah, exactly. If all results are equal to one means it's a perfect normal distribution. But if all the values are closer to the mean, or if the median is closer to a mean, and in that those in a see here the mean is 171 and here the median is
170 to
172
170.
and here
Yes.
it's 170. So which means it is closer to the mean. So this
Yes.
data is following a normal distribution, we can assume.
Yes.
Okay. So when the mean and median and a mode, all three will be equal to 1. In that case, we can call this as a perfect normal distribution, or it has to be at least closer. If it is closer to the mean and all these values are closely associated, then we can call them as a normal distributed data. Okay, Raghav, Sashi, you are getting this concept.
Yes, sir.
This is the base for statistics, right? So for anything that we are going to do with the data, first thing that we will be doing is compute mean, median, and mode, and trying to see like how the distribution of the data is. And then only we can start with anything else, right? So this is like our Lord Ganesha. So without praying to Ganesha, we cannot start anything.
Yes.
Same way, without knowing the mean,
Muhurta.
median, and mode, you cannot do anything in statistics or models. So these are like basics. So
Yes.
if you are not computing this and trying to understand the data and trying to do big things in the model, it will fail in case if the base things are not going to work fine, if it is having some issues, right?
Yes.
Okay. So next is something called, we'll be seeing about measures of variability of data. Okay. So next is how the spread of this data is there. Okay. So the same data what we have taken, what has been the spread? If someone is asking you, how is your data spread across? How will you tell this? What is the spread of this data?
I don't know. It is between 160 to
Yeah.
170.
So basically
170.
what you will say, how is your data distributed? If someone is asking you, you will basically say, my minimum value is 160 and my
Maximum value
maximum value is 190.
190. Median
So
is 170.
mostly my data is spread between 160 to 190. That is what we will be saying, right? So
Yeah.
the same thing is what you will be saying here also. This is also called measures of variability. So here what we also do is we basically try to find out the difference between two measures, which is the minimum record and the maximum one. We try to find
Okay.
the difference between that. So we call this in statistics as range.
Okay.
Okay.
What range is the data?
Okay. So this range, what it does basically is, so you take it is already available in NumPy, so I don't have to import SciPy or something. So I just take np.max. So from this data, what we are having, we'll take the maximum data, right? And from this data, we'll be taking the minimum data. And we'll be trying to find the difference between the maximum and the minimum. Okay. So what is the difference between maximum and minimum here? It is 30.
30.
So basically what we can tell now is this particular data is spread across the difference between maximum and minimum is 30.
Variance between maximum and minimum.
Yes, exactly. So basically, when this will be more useful is basically range is a very simple measure, right? So it is just trying to find out like a quick initial look of the data whenever you wanted to analyze some information. It helps you to see the gap between the extremes in your data. So basically, what they generally say is, so how has been the distribution of salary if someone is asking? So basically, the organization will be saying, what is the difference between highest paid and the lowest paid employee in the organization? So, and understanding this gap is basically going to help us like how are we going to bring that lower person to higher salary so that it is more of normally distributed kind of.
We can't say count also, sir. We can't
Uh,
consider.
no, not count. Basic count of what? Count of
Means, for example, in 160 to 190, we have
hmm.
variance is different 30, but we have 1 million records. So
Yeah.
how this we can't consider the size of the data.
No, it doesn't consider the size, right? Because it just takes the minimum and a maximum. And the difference
Okay,
between the
the range.
maximum and minimum.
Okay,
Yeah, for range.
the someone asks about range, we can't consider the size. Just we own difference between min and max.
Just the min and max only. Will not be considering the size, sir. Yes.
Okay.
Right. But so okay, one question to you. Is this affected by outliers or not? Range?
Which one? It not
Not?
not affected.
Raghav, will this range be affected by outliers? Maybe he's not there. Okay, let's try it out, right? So I'm
It's
giving an
now
outlier.
if it, yeah, if
Yeah,
it will affect.
it will affect, right?
Yeah.
So like mean, unlike median, range will also get affected by outliers. You see
Yes.
here now it has become 840, right?
Yes.
So it will get affected by outliers because
For example,
whenever you are
sir, for example, we have data to one, for example, 100 records, not just
mm,
simple. We have incremental
mm,
of 5,
yeah,
162, for example, 1000. We have
yeah,
165, 170, 172, incremental 5 difference
yeah,
only. It will
yeah.
be not outlier, right?
No, it will not be outliers. It will not be outliers. See, outliers are something. Okay, I'll tell you what an outlier is. So, for example, if there is heights of students are there, the
Yeah.
height of a student cannot be like 100 meters, right?
Yes.
Or if it is represented in meter, the height maximum it can go till 2 meters. So
Yes.
after 2 meters itself is very tall, right?
Yes.
So if it is like 100 meters height,
Yes. In heights it will not. I'm sure.
yeah,
But
yeah,
I will give you one example. For
yeah,
example, salary.
yeah,
Okay. So for
hmm,
example, mostly we have the medium salaries. Some of
yes,
we have the new gen is lesser salaries.
yes,
There is a outlier is CEO and
yeah,
directors are CEOs. Okay, CEO and VP. Okay,
yeah,
these
yeah,
are the outliers, right?
hmm,
How we can means it will be, for example, from we have 1,000 to 10,000 to 1 lakh the salary. CEO
yeah,
is 1 lakh. The
yeah,
median is until 170. It will incremental
yes,
by stay our position. Then
correct.
how we can we do this?
Okay, yeah,
We
very
can
good
consider how we
question.
can consider.
Very good question. So, whenever there are this kind of outliers, before computing a mean or a median or a mode, so basically, when there are more outliers like this, right, we generally don't consider a mean or a mode. We directly take a median of this, right? And we try to say like out of 1,000 employees, the 500th one, after sorting it the order, then that will be considered as a median.
Okay.
So median salary is almost like 20,000 something, right? So that
Okay.
will be considered as a median, the range of your particular data. So you will not be considering range also there, because range will be more skewed. Or what you generally do is you try to normalize this data. So how do you normalize? We basically take all the records and we try to do the max minus min divided by max, and then try to represent it within 0 to 1, right? In that case, then it becomes more of a comparable format, right? Or also what we can do is we will transform this data. What we'll do, we'll take a square root of this, right? Or a log of this. So in those scenarios, what happens? The entire data gets transformed into a more comparable format, and then we can take a mean or a median or more depending on the scenario.
Okay.
You got it, Sashi?
Yes, got it, sir.
Okay. I'm not sure. Raghav was there. He's able to, I hope he is able to hear us well.
Yes, sir. Yes,
So,
sir.
okay. Okay, Raghav. Good.
Yeah, too much of noise in.
In your side, okay, okay. Fine,
Yeah,
no
here
problem.
opposite board is running, so that way I'm muted.
Oh, nice, nice. Okay, okay. Yeah, yeah, yeah. They do digging, boring. Yes, I understand. Yes, Raghav. Okay, great. So let's see one more concept and we'll end today's session. Okay, so from the sample data, now we saw this. I'm going to show you one more concept called standard deviation. So for the same data only, let's compute a standard deviation. So how to, yesterday we saw the formula for standard deviation, but we have not computed the standard deviation yet. So in NumPy only we have a module called STD, and we'll be using this STD, we'll be computing the standard deviation. Okay. So now this particular data is taken. So for the same data, I'm not sure whether did I add any outliers to this or no, I don't think it is there. Let's see the standard deviation. What this 8.7 says. So a lower standard deviation. So is this a lower standard deviation or higher standard deviation? So for your question, Sashi, you told, sir, the salary is just increasing only by very few numbers, like five only. But there are 1,000 records, there is an increment. So there is a difference of only 5 or something. But now what happens? It computes first a mean. Okay. And it takes a square root divided by yesterday's formula we saw, divided by n minus 1. And then it takes a square root of that value. So basically what the standard deviation will tell us, how much is the deviation from the mean. So how much the value has been spread out from a mean. That is
Okay.
what will be estimated by the standard deviation. So this is saying the mean, the standard, this particular values are away from the mean by 8.7, which means just by 8.7 only the difference between the mean and the spread of this data is ranging, which means it is basically saying not very large difference. So basically what it is saying is my mean is 171. So maximum it is going until 180, or 190 is very low. So but maximum is 180 is what the most of the deviation is here. So which means it is saying 190 is one record only. Rest all, if you see, it is a maximum. It is like another 8.7 more than the mean. So what is my mean here? It is 171. So 171 plus standard deviation will be giving me my the records, whatever is there actually. But it need not be the same records there. It is just saying within that range. So it is not deviated so much from the mean, is what this particular standard deviation is basically helping us to understand.
Means it will from the mean to 8 points.
Yeah,
You can say.
8.7. If you just add this 8.75 to the mean, that becomes your that becomes your data itself. Your
I
data
mean,
is the data, all data are like not too much away. They are just like 8.7 away from the mean.
means
So
it will be 8 points. Means it will 0 to 1 between 8 points, or it will
no,
be.
not between 0 to 1. It is, see, this standard deviation can go in hundreds, thousands, and even more also, right? So
Okay.
generally, as you know, if it is less than, like, if it is closer to the mean is better. So your mean is
Okay.
171. So your mean is 171. Let me take this, our diagram. So this is your mean. Okay. Here we'll be taking, and this will be our, so what will be the mean? The mean will be here.
Yes.
Okay. So this is my mean. And yesterday we were seeing this concept. One standard deviation, two standard deviation, three standard deviation, right? So
Yes.
assume like a mean is here, which is 0. So
Yes.
this will be like one standard deviation for us. This will be two
Yes.
standard deviations. And
Yes.
this will be three standard deviations. So
Yes.
mostly if it is closer to the mean, it will be here, which means it is not deviated that much. So we can consider until two standard deviations also, or maximum until three. But more than this, we cannot consider because it will be
The
too far
standard
away.
deviation is value 3.4 million per product.
No, standard deviation is 8.75, what we got there, right? So
Yes.
that basically says my mean is 170. So my mean value is 170. It is here. Where is this text box? Yeah. So my mean value is here,
Here one.
170,
Okay.
right? And the standard deviation is after this 171, it was there, right? 171, I think. So 171. Okay. And the standard deviation is 171 plus 8.75. So basically the value is around 170,
196.
179 or 180,
Yeah. Yeah. Yeah.
right? It is
Okay.
here. So which means it is within one standard deviation only, we can say. So it is not
Okay.
that high, right?
Okay.
And
Means
if it is
before
yeah, it can be before also. So
it can
this
170
171
minus
minus
9.
plus or minus 8.75. So it can be like
Okay.
171 minus 89
Okay.
also.
Means this
So
100%
basically,
data will be between this standard deviation means.
no, standard deviation basically what it tells us is, this basically tells us how much the mean has moved out, the spread out
Yes.
of the value from the mean.
Yes.
So
Yes.
basically here a low standard deviation means the values are closer to the mean. Higher
What
standard deviation means they are spread out more. That's
what is
what
the
it.
number we can consider as um, closer, and
Okay.
which is higher? Which number
Okay.
is
So it
more
depends
than
on the
that?
data, right? It depends on the data. So here, for
Okay.
example, if we have considered 160, 170 as the mean, 171 as the mean. So now 8.7 added to this 171 will be my maximum. So most of my values will be coming within this range, plus or minus this. So
Yes.
it will be, so this is not spread. That means this data is normally distributed, we can say also, just to
Yes. Yes.
think, right? So if it is too high, so assume like this standard deviation is plus 100. Okay, let's
Okay.
take an
Plus
example,
100.
right?
Yeah.
Let's
Got.
take an example. So let's take 1000. Okay, let's take 1000 as an example. Now you know the mean is what? Mean is 240. right? And now let's take the standard deviation. You see?
Yeah, yeah.
Now, from the mean, this has now like increased. So mean is 240. It is saying the standard deviation is 229 more than the mean. Okay. So now what it is clearly saying, there is some issue with the data. The spread of this data is too much, is what the standard deviation is basically trying to help us. So since there are very few records, we know by seeing only, we know there is some outliers. But when there are millions and millions of records, we by naked eyes, we will not be able to see and tell, is there an outliers or not. So the standard deviation is also one more measure to help us see the spread of this data. Okay. So the higher the value, the higher the spread, and there is some issue in your data, you can assume. The lower the value, the lower the spread of the standard deviation. So which means the data is following a perfect I think it is closer, we can assume.
Yes, sir.
Is this clear, Raghav, Sashi?
Yes, sir.
No, sir, I
Okay.
have some confusion.
Yes. What's your question, Raghav? Please.
Full numerically how to fraction of second how to I calculate the values of
Fraction of a second. How to calculate what values? Standard deviation?
yeah, everything mean median those values also.
Okay. See, that's what we saw, right? So we have inbuilt functions in NumPy. So you just need to make use of these functions only. So for example, here for mean, what you do, you just say np.mean. For median, np.median. And then mode also, you just import the stats module and then ask for a mode. Range is also available in NumPy itself. See, all these things will be, you have to manually compute it, or there are metrics by itself. I'll show you that. So whenever a new data is there, there are some inbuilt methods which by default will bring you this mean, median, and mode, standard deviation, everything. The Python itself will compute. So once you describe the data and show this, automatically Python will compute and show it to you. But why we are seeing this in detail? Because when Python is showing at that time, you should also know like how this is getting computed. So you understand the concept clearly there. So when we are going to see with the real-time data, it should not be like, okay, what has happened? Why this is, what is this? You should not get those basic confusions there, right? So it can directly get computed. So we can make use of Python's inbuilt capability. We'll be seeing about that, right? So for now, what you understand is, make sure how are we going to compute the mean, median, mode,
Median.
standard deviation, range, and
Yes.
all these things. How are we manually going to compute using Python? We are seeing.
Before proceeding into the project.
Yes, exactly. So now what are we doing? We are making the basics clear. So without this, we cannot do anything there, right? So there are people who are doing without knowing this also, but their journey will be very short-lived,
Yes.
short-lived journey,
No
and they will
foundation.
not be able to solve the real-time complex issues or problems.
Yes, sir.
Is this clear, Raghav?
Yes, sir.
Okay, great. Okay, perfect. Then, so if no other questions, then let's call it a day.
Yes,
Raghav,
sir.
Sashi, let's
Yes,
continue
sir.
tomorrow then.
Yes, sir. Sure, sir. Tomorrow
Okay.
will be
Yeah,
binomial.
yeah. No, tomorrow we'll be seeing about some more advanced concepts, because now the basics are clear for you. So
Yeah.
using these basics only, the other concepts will be coming up.